Hello, my name is Craig Gallen. Welcome to session 2 of the OpenNMS tutorial series. So this diagram gives you an overview of the location of various files within an OpenNMS system. And the layout of files is pretty much exactly the same within a container as within an OpenNMS system that's been installed on a standard Linux distribution. So in a distribution, we will install OpenNMS at opt-OpenNMS. Now, on a Debian distribution, that may show up in the share directory, and these opt-OpenNMS files will actually be symlinks to the share. But the basic principle still applies. If you go to opt-OpenNMS, you will find these files. Now, quite often, we initialize the etc directory as a Git folder using a Git tag, because quite often what you want to do is keep version control on what's in that etc directory. If it's been running in a container, then that doesn't matter because the etc directory is going to be injected from outside. But in a full install, we usually use Git in the etc directory to keep track of changes to the configuration that happen over time. The bin contains the starting file to start and stop OpenNMS. The contrib contains various contributions to OpenNMS over the years. These are variously documented, and I'm not going to go into them in any great detail. Some are more useful than others. Data, deploy, and a system are all actually, and instances are all actually related to the carafe container which runs in OpenNMS. Deploy is where you would deploy plugin car files. Data is where carafe stores its own data. Instances is another place where OpenNMS stores its running data. And the system directory is a Maven directory which contains the various components that carafe needs to start up. The etc directory is where most of the configuration for OpenNMS is done. Occasionally, you may have to do some changes to Jetty web apps as well to modify how OpenNMS connects to authentication mechanisms. And then the share directory is where OpenNMS stores its RRD files, its saving, but also within this file, we've also got a pristine etc directory, a number of MIBs that we may wish to reference, and XSDs corresponding to these pristine etc files. Now, in a container, this will be set up exactly the same way, but we set up the container so that the OpenNMS overlay is going to be copied into the etc directory. When OpenNMS starts up, it copies the files out of OpenNMS overlay into its etc directory and runs with them from there. They will not change in OpenNMS overlay if they're changed within OpenNMS because there's no direct link between those two folders. The OpenNMS deploy directory, however, is directly linked to the deploy directory for the carafe container. So any files that are dropped into deploy will end up in the OpenNMS deploy directory and will spin up a new plugin if it's a car file containing a plugin. Containers start up somewhat differently to a normal OpenNMS installation, and we use a technology called confd to set the configuration in a container. So you'll see that there are environment variables that are set within the container to set up database port values and stuff like that. Those are actually used to modify the OpenNMS data sources file within the etc directory. So if I go to my OpenNMS installation and I log into it, if I look at the data sources file, you can see that information has been set up here in terms of the name of the Postgres database and the username and password for the Postgres database. Those come from the environment variables that are injected into the container. And so the process is that when OpenNMS starts up, the first thing that happens is that the conf_d is run. Conf_d uses these various environment variables to modify some of the files in the etc directory, and most importantly, it's this OpenNMS data sources file that's modified. As we can see here, it's been changed. That is filled in with the usernames and database names that are actually provided as environment variables. After that, any files in the configuration are copied over the etc directory. So the point being that first of all, the environment variables are applied to the existing files, and then secondly, those files are replaced if if there's alternative files being provided by the Docker Compose project. So that way we've got a lot of control over how OpenNMS is set up in a container, but we can also use these environment variables to set up certain bits of information. So container files can be modified through the UI, but in order to do that, we first have to set up the user to be able to modify those files. So we need to put this role file system editor in place. So let me do that on my OpenNMS installation. I'm logging in as admin user. And I'm going to configure users. And I'm going to modify admin. Now, what I need to give them is this role of file system editor. And then I need to save the change. And at the moment, under info, you can't actually modify the file system. But if I log out and then log back in again, and then again look at info, you'll see that we are now able to edit the files. So we can see within the etc directory the various files that are there that can be modified, and we can change them. But remember, because this is running in a container, if you change these files, they will not survive through the restart of that container. They'll just survive for the length of time that you've changed them. So when we are doing work in a container, we really need to modify the files externally and copy them into the container. But when you're working in a normal OpenNMS installation, if you modify the files here, they will stay persisted with the system and will survive a restart, which would not happen in the case of a container. However, it's quite useful to be able to modify the files for our purposes as we're doing a few exercises. So I'm going to go now to exercise 2.1, where we're going to look at how we can change the SNMP community strings that are provisioned in OpenNMS. So here we are in exercise 2.1, and the Docker Compose file that has been set up for this exercise has the SNMP containers that we had previously, but it also now has SNMP Sim. Now, SNMP Sim is a project which allows you to simulate an SNMP agent using an SNMP walk. So I have gathered SNMP walks of this particular camera, and I'm running them in SNMP Sim. Now, I have what is called a requisition file that contains all of the information associated with these devices. Previously, we used discovery to discover nodes within the network. But now I'm going to tell OpenNMS what nodes it needs to look at. And I'm going to do that from the web console. So if I go back to manage provisioning requisitions, and you'll see that there are two requisitions here. One is the test network. So let's look at this test network one. And you can see these are all the devices that are included within this example. Okay. Now, what I'm going to do is I am going to synchronize this repo and scan all the nodes. And you can see these are the devices that have been added. Now, you will see that I haven't actually added the SNMP sim in this example yet. So we need to look at that. So the SNMP sim from our example was 172.20.0.103. So let me go to my provisioning requisition again. And I'm going to add that extra node in. Add node. I'm going to call it chub. It's in the local environment, so I don't need to change that to a different, it's going to be default. And I'm going to add an interface on, and the interface is going to be, if I go back to my tutorial, 172.20.0.103. Okay, and just add a service onto it, ICMP. Save. Okay, save that, return, and I now have an extra node here. That's in this case it's called chub. So I'm going to synchronize that, and we should see chub showing up. Here we go, at the top. Now, it hasn't been able to detect SNMP on this device. And the reason for that is that the community string is not correct. So it isn't responding to any SNMP gets. So what we do need to do is to change the community string for this particular device. And in our tutorial, we've got examples of how we can actually change that community string. If we go down, we can see that we've added this node. Now what we want to do is we want to add the community string associated with that node. And then we do that using configure SNMP community names by IP address. So let me go to that command. Yeah, right. So it is set up. Okay. Save the config, make sure we're happy. Now if I go back to the nodes, under the chub node, if I just rescan that device, and there we go, we can see that we've got this information now corresponding to that node because it's responding to that SNMP get with the correct community string. So that's exercise 1. We've basically set up the community string, we've set up the requisition, and we were able to pull in the node information that we need. Now, 2 things to say. The SNMP config is the file where that folder is held. So let's have a look at that file where that information is held. So we're in the etc. directory. And you can see that under the SNMP config, we've got a read community chub for these specific IP addresses, 172.20.0 to 103. I must have put that one in by mistake, but that's fine. Okay, so that's backed by a file. And also, if we look at the requisition, we can see that test network 1 requisition and again we can see that all of the nodes in our requisition, including this new one that I've added in, are in that requisition. Now this requisition file backs the UI, but it also can be posted into OpenNMS in order to post in a requisition with all of the data that might be held in it.